Hi Shared Hackers. Some viewers have asked us some questions about the train project and wondered whether we'd put some lighting in it and possibly even a motor. And I think we will. And one of the circuits involves it sensing light or dark, and so the lights come on automatically. And here's one here I think I'm going to do in a later clip with my son. Okay? And we'll talk about the components and how we can get it all working. Alright? And that should be quite exciting for you to look at later, hopefully. Okay, moving on. I thought it's also a good opportunity because several of you have asked what components we might need to use. A little bit about basically electronic components. So this clip really, or the next couple of clips, is all about electronic components. So I think, Jake, if you just scan across quickly the table and see what we've got here, a real collection of items and componentry and components. And you can see it's more modern things like the liquid crystal here, a motherboard from the computer. And we'll go back to that in a minute. So if we pan slowly back to the beginning, and we'll start off with how things are generally connected in circuits and electronics. Well, the basics are wire, of course. This connects one part of the circuit to another, one component to another. And we use aluminium, or we can use copper. Well, Jake, you know the really high quality material we could use is
gold.
Gold, and gold's used in space stations and all sorts of very intricate electronics, including computers. And gold is probably one of the most efficient ways of conducting electricity and heat, actually, interestingly. Titanium's another one as well. Right, so moving on, what we're going to do is look at some connecting methods. So we've got wire, and that's copper wire but tinted and solder. Solder is a mixture of tin and lead. And there's a bit of ribbon cable. You can actually see the markings inside. There's a connecting block, so you can connect one piece of wire to another. You often see those in circuits, connected on the circuit. And then we have the batteries. So we'll move on to batteries in the next clip.
So moving on, we've got different types of batteries here, and one of the most common is the AA battery, and this one is rechargeable. And then this is a D size battery, which is quite a big one and is used in quite old big torches. And then we got the 18650 battery, and it's used in laptops because it has a really high energy output. And then we've got the 9-volt battery. This one isn't rechargeable, but it's still quite good for small electronic projects. Then we got the AAA battery, which is essentially the AA battery, but a bit smaller capacity and smaller size. And then we got the C-size battery, which is also used in torches and that sort of thing.
And I can see there's a couple of other ones here. What are these?
And these one, so this is a button cell battery, very flat and thin.
And what are they used in?
They use in like scanners and sort of medical equipment sort of thing, or even watches.
Yeah, the mini ones I've certainly changed.
And this is also a button cell. Now this is something you may not see that often. It's a battery from a phone, and it's one of those batteries you can swap round.
Brilliant.
So yeah, that's from an old phone.
Thin. And what's inside there? What's inside that?
So inside this one is lithium and iron.
Oh, right. Is that good or bad?
Lithium is quite hard to work with because if you get the current wrong or the amperage or something like that, then they can catch on fire or smoke or something like that.
And is cobalt used in any of these? I think so. I hear cobalt's now.
Cobalt is normally used in these, and Tesla used them in their batteries, but apparently they're trying to eliminate cobalt.
Why is that?
Because it's extremely hard to mine, and it's can be quite dangerous to the
Okay.
environment if they don't do it properly.
No, I think you're right. Hi, shed hackers. Moving back to a little bit to the sources of energy, as well as batteries, you can use solar cells, of course, and this is a 5-volt solar cell, and it only produces about 0.01 of an amp. But you can get very large ones on houses, and they can really be quite useful and effective in generating electricity. Talking about mains electricity that comes into the house via large cables under the ground or even overhead, the plugs in your house supply 240 volts alternating current AC, and these transformers plug in and then they step down the voltage or up the voltage to above 240 in some cases, and then much lower down to about 5 or even 2.5 volts depending on the actual equipment you're running. And that's what the sort of type you tend to see, sort of charging transformers, and that typically go down to about 20 volts. And these are the ones that are hidden inside large devices like perhaps large televisions even, or even large computers. And there's a similar one there, and you can see they're made up in the same way, and they have 2 coils, a primary and a secondary coil, and one winding of wire allows electricity to not conduct, transfer to the next through induction, sort of induction method. Okay, so moving on, we've got the battery holders that we should have mentioned really, which are obviously combined with the batteries. These are moving on to capacitors, and these are various types. We have electrolytic and non-electrolytic, and they clip the frequency in circuits and stop sparking across switches and things. They're used temporarily to store an electrical charge, these the bigger ones, and sometimes they're even compared to small batteries, although they're not really in any way. They discharge much more quickly, but they can hold a very high charge for a short period of time, and you can get monostable types and astable types. The units is the farad, and you can have microfarads, that's 10 to the minus 6, nanofarads, 10 to the minus 9, those mathematicians of you, and picofarads, that's 10 to the minus 12 farads. So that's an awful lot of noughts on that one. And you know, these are used extensively in pretty well every electronic circuit. Okay, moving down, Jake, we've got some potentiometers here, which are variable resistors, and the variable resistors really do the same job as the preset ones here. There's another little variable there, you can adjust that with a screwdriver. And these are fixed, so the resistance across these is fixed. Now, interestingly, the resistors are used in pretty well every circuit you'll come across. And if Jake just pans over to that computer there, alright, you can see how the resistors are used, and they're actually very miniature. They're really miniature, some of them, and inside the silicon chips they're so small they're microscopic. That's the word, I think, isn't it? Okay, we'll come back to resistors in a minute. And going back to resistors, we did a little bit of research, and you can see from this book, Jake, there's the colour code, and the colours, the bands on each resistor denote a certain value. So that's worth knowing. A little bit of research for some of you, perhaps. Okay, I won't go into it now. Thank you, though. Right, so moving on, we've got then a filament fuse, and you can see there, I hope. Can you see that, Jake? Can you come in? Yeah, you can see a little fuse wire in there. That blows if the current in the circuit's too high and dangerous, and that's one often you find in a plug. And often it says on it what value it is. That one's 5 amps. Can you see? 5 amps. And this one may be milliamps. That's a thousandth of an amp. Really small. And then moving on again, this is a relay, often in a box like that. Here's one you can see inside. Can you get that, Jake, there? And a relay allows a small voltage to trigger a high voltage, and you can see the little switches in there. Can you hear them there? Little switches. And there's the coil, and the coil's energized, and it actually flicks the little copper levers over, and it allows current then to flow from one side of the circuit to another. So it's a safety device, really. So you may use that perhaps on a machine where you don't want to be touching the actual high voltage side, you only deal with the low voltage side where it's safer, but it activates a much higher voltage on perhaps another side of the circuit. Right, this one's quite good. This is a reed switch, and a reed switch works with a magnet, so it's a type of switch. Don't know whether you can see that. Can you see it moving? Yeah, I saw it move then. Alright, that's a reed switch. And that's used for security devices indoors and all sorts of things, often as a safety device. And then you've got a thermistor, senses heat. That's a thermistor. A thyristor is an electronic switch, very clever thing actually, and it latches down. So once it's been triggered, it stays on, or it can actually be designed so it stays off. So these can be used in safety circuits as well, where you don't want something to go on and off. It latches off and stays off. And then you've got silicon chip based circuits, quite complicated. These are often used for rectification of circuits to transfer from AC to DC, and small TDA 7000, often for running a 7-segment display. So Jake, I'm just going to show them that. That's a 7-segment display, you've seen those. So these little chips here often are used with a combination of other resistors to run these. And then transistors, solid state, some people call them. Transistors are used in amplification to make a signal length higher and stronger and more powerful, and they're often used as switches as well, but sort of a very quick and sensitive electronic switch, so they can sense very small changes in voltage, and then switch a circuit so maybe a light goes on. Okay, moving on to diodes. We've got diodes that are hidden inside a 7-segment display. Got diodes on this circuit board, and they're all different colours. The colour is how the electrons are dealt with inside. It's not necessarily the actual colour of the plastic. And here they are without being soldered. This one, in fact, if I put electrical charge in it, would actually change colour. Red, blue, and I think green. But some are just one single monocolour. There's a really large one there. It's fantastic, isn't it? That's a 10mm one. These are about £1 each. There's a diode there that allows current only to flow in one direction, but you can get diodes in a combination that transfer AC or DC current back to AC, but it's normally AC to DC, and that's in rectifiers. I think I mentioned that earlier. I think there's a signal diode often used in radio circuits, and that deals with frequency levels in circuits, and also low voltage. And there's a Zener diode that allows current to flow in one direction only. So they're all diodes, but some are lighting ones and some are more to do with just circuit control. And then moving on here, there's filament bulb, good old filament. You probably use those in primary schools, I hope, in some way. See the little filament, sort of out of date now, taken over by the LED. And these use a lot more energy as well. That's why we don't use them in street lights. Talking about street lights, Jake, that one there, that's an LDR, a light dependent resistor, and these detect light levels, and once it's detected certain light levels with the use of another part of a circuit, it is then used to control whether the light goes on or off. So street lights, often you can see them go off and on depending on the light levels, the natural light levels. This is a microphone, a mini version of that you'll find in all sorts of equipment, including cameras and your own phone or iPad, whatever you got. And there's another version of it, but the much smaller version you'll see in your phone. And then I'm going to move on now to switches, and I think Jake's going to talk to you a little bit about switches and then motors.
Okay, so moving on to switches, we have these quite big ones, commonly used in like cars and those sort of things. I think they're called toggle switches. And then we got these small depressant switches.
Depressing?
I mean small press switches.
I think they're called momentary switches, where they're on momentarily, like in an alarm clock when you reset it. good.
And then we got these slide switches, which have like a little lever, and you can slide them whatever way to turn it on and off.
Yeah.
And then we got these ones, which are quite amazing actually, because they use a little rod, and that's a little switch there.
And that's called a micro switch, often used in security doors and so forth.
Yeah. And then here we got Donald Trump's big red Twitter switch.
Very clever, yeah. Do you think he's got one of those on his phone? Probably has.
Probably.
Okay, moving on.
And then we got these little toggle switches, which just work by going side to side. They're a bit like these ones.
Yeah. Yeah. They light up as well, those.
Yeah.
What about that odd one at the back with the key in it? What is that?
This one, I think when you put the key in it and you like turn it,
Yeah.
it makes a signal and then turns something on.
I think it just, yeah, you're right. It makes an electrical connection between one of the 4 contacts at the back. So turn it, that's it. So at one point it connects 2 together, and another point it connects another 2 together, or disconnects depending on how you've turned it. Brilliant, yeah.
And then this one's just an on switch.
Push to...
Push to make the circuit.
Yeah, good.
And then this one's a push to disconnect the circuit.
Push to break. Yeah, push to make, push to break. Good, okay. And we'll move on to the motors. Off you go, Jake.
So we got this DC motor. You can tell that because it has brushes.
And what's DC mean again?
Direct current.
Yeah.
And this is found in like a hairdryer, that sort of thing.
And what are those things there? Well, I can see some odd bits of brass there. What are they?
These.
No, the brass. That's the copper. Yeah. What's that?
This is the commutator.
Oh, yeah.
And then that there are the brushes.
And that allows it all to connect and spin. So,
Yeah.
in effect, it's a big... what sort of device am I trying to say? Electromagnet in some way, isn't
Yeah.
it?
That is actually how it works. It has some sort of an electromagnet, but that's a topic for a different video.
Yeah, that's clever, though, aren't they? How they work,
So then moving on, you got these ones commonly used in small toys and school projects because they're fairly cheap and they are DC motors. These ones are used in portable fans because they're really small and flat, but generally more expensive. This one is actually an AC motor, which is a fan from a computer, and AC is alternating current, and it has no brushes in it, so it will wear out a lot slower and last a lot longer. Here it's literally just a bigger version, probably what you'd find in a more powerful fan, or maybe even a small hairdryer.
Yeah, or even a small drill. Have you got a drill motor? No.
Maybe.
Now let's move on. Okay, so that there. If I give you the camera, Jake. Great. Look at that. Clever. This is a liquid crystal display, LCD display. Great turnaround in technology that allowed this to happen. And this actual type of circuit is probably about 20 years old. But you know, liquid crystal. That means actually a liquid carrying an electrical charge, allowing it to glow. In that case, polarize, it's called. Some memory chips, memory slots there go into the computer.
They're actually from a laptop.
Yeah, and they're often put in. There's a bigger one there. The motherboard here. We'll move the lights, you can see here. You can see the output parts to it, what they're called peripheral parts here, for audio out, and the landline internet fittings. More connections for more memory, or even the ribbon cable that goes in that connects to another part, like the power supply, the actual main driving chip, CPD, the central processing unit. Look at the little capacitors used, and there'll be microscopic versions of those hidden inside the actual silicon chips, if they still use silicon. We're still not sure about that. I think they've moved on. Now some of these have multi-layers. It's not just one layer, it's a layer on a layer on a layer. It's really clever technology. And if I turn it over, see some of the soldering. Great. Right, and then we've got the loudspeakers and the piezoelectrics is a sort of more modern version of producing current, and it uses a vibrating crystal between two metal plates. Really clever actually, and they're using buzzers and all sorts, and they are very efficient and give out a lot of sound. And of course you get a range of speakers. You can get massive versions of this, 15-inch speakers used in hi-fis and public address systems. There's an old buzzer. There's a mini version of a speaker I got off a toy actually, and it's got a plastic cone. This cone on this one is cardboard. And as you know, there's a magnet and a small coil in that, and Jake will tell you how it works. How does it work, Jake?
So the magnet is a permanent magnet, and inside here is a small coil, and when you pump electricity into it, it sends an electric charge which moves this little bit of cardboard, and it moves out and in like that and creates a sound wave. And depending on how big the sound wave is if it's low pitch or high pitch, and that's essentially how a speaker works.
Brilliant.
Very simplified.
Oh, you're very knowledgeable, Jake, today. So we'll just scan over all the components. I mean, for some people, this is really quite interesting stuff. For others, as you said before in some of these videos, not so enlightening and interesting. Oh, my son's just found another larger motor.
This is a large motor from like a 3-volt screwdriver sort of thing.
Oh, right.
And if
Powerful.
you look in there,
yeah,
you can see it has a mini commutator.
Yeah, just there, yes. Turn it the other way. I'll turn the camera. I can see the copper wire in there as well.
Yeah.
Brilliant.
And this is basically a small version of this motor, and they're both DC.
There you go. So there we go. Look at all these components. Little amplifier there. Look, I can see with the phono out, and the little amplifying transistors to the sides. Did I talk about a thyristor? That's a thyristor there. Yeah, I did. Latching.
One more thing.
This? Yes,
These are heat shrinks.
Shrinks or
Heat sinks.
sinks. Not shrink. Am I?
They don't shrink.
Yeah, no.
So they're in computers and places where the electronics will get quite hot, and they're there to displace heat. So they get hot, and the air can pass through and get rid of that heat. And this is a much bigger one from an amplifier.
What's an amplifier again?
An amplifier is it adds power to
a
the
sound signal,
speakers or the sound.
Sound makes it larger, so you'll have a smaller signal amplifier to be a much larger one for an amplifier. Right, okay, and there's a little circuit there. If you turn that one over, oh look, we can see the actual symbols. Let's just go through a couple of symbols quickly. We've got the transistor and the base collector and emitter marked on it, and we've got the little resistor there, code. Jake's pointing at the diode there, should have a circle and two little arrows coming off it really, and then the symbol for the battery.
That's actually a symbol for a battery cell, as I was taught in my science class.
Yeah, and the larger side is positive, as you can see. The symbol for the LDR is not on there.
Well, here you can either have the LDR here or here, and it's made to have one of these variable resistors, and you can switch them around depending on what circuit you want.
Right, good. Okay, I think we've done enough now to completely bore you. Hopefully not, but we find it quite interesting anyway. And we'll come back to you when we're making this circuit. Happy days.